Hello viewers, this video is about the simulation of rotational mechanical system in MATLAB. To draw the circuit, we need Simulink. So click on Simulink and then create a blank model. Let us take the rotational system as given in the figure, which consists of moment of inertia J, a damper, and then a spring. Let us take J to be 10 kg meter square, the spring constant K to be 1 Newton meter per radian, and the damping coefficient to be 2 Newton meter second per radian. And let us take the input torque to be 20 Newton meter. In order to draw the rotational system, we need inertia. So type inertia. And then we need a rotational damper. And then we need a rotational spring. And let us change the value of the damper to be 2. Then let us change the value of the spring rate to be 1. And the inertia to be 10. Now we will connect all the elements. Then we need ideal torque source. Control R to rotate the torque source. Connect the R terminal of the R to the junction of all the 3 elements. Then we need to connect all the common terminals to the rotational reference, mechanical rotational reference. So type mechanical rotational reference, and we will connect all the common terminals to the mechanical rotational reference. In order to run the model, we need a solver configuration, which need to be connected to the reference. Then we have to give a torque of 20 Newton meter, which should be given with a step input. So take step input, and let us take the step time to be 0.01, and the initial value to be 0, and the final value to be 20. This step is in the Simulink environment. We need to connect this to the Simscape. So we need a PS to P. We need a Simulink to PS converter. So we can connect the step to the ideal torque source through the Simulink to PS converter. Then in order to see the output, we need scope, which is also in the Simulink environment. So we need a PS to Simulink converter. And let us measure the input and the output. So we will change the number of inputs to be 2. And to measure the output, we need ideal rotational motion sensor, which will measure the output, motion. So let us connect the input of the ideal rotational sensor to the junction of all the 3 elements, and then the A terminal to the PS to Simulink converter. And we need to connect the common terminal of the sensor to the reference. And we will see the output and the input dark waveforms. We will see the output motion waveform and the input dark waveform. Now the circuit is ready to run. We can run the model now. And before that, we can have the names for all the elements. Now we can run the model. So we will be able to see the dark input and the output motion output, but the motion output has not yet settled down. So we can increase the stop time to be still further. Let us randomly choose 50 and run. Oh, now we can see that the motion output, that is motion output, is of a damped nature, which is having its damped oscillations. The oscillations are getting damped out to somewhere around 45, 46 or 47 seconds. So this is the output motion, and the yellow line shows the input dark. Thank you.